Now, let us see the hypothesis representation of this formula. Okay, now as I told you that we have, let me take another one. As I told you that we have some data like this here, okay, and we have the other set of data like this. Now let us just draw a line here. Now let us put it in hypothesis representation. Okay, let us put it in hypothesis representation. Now, according to the regression problem, we can say this h theta of x is equal to theta, this line is theta naught plus theta 1 into x, right? Now, we have seen that what I would like to do here is I just wanted to express this in terms of our sigmoid function. Okay, now what I would like to do here is I can just say that let z is equal to theta naught plus theta 1 into x. I can say this, right? I'm just giving a variable z here. Now I just simply say that h theta of x, I'm just converting it to a sigmoid function which is g of z. Okay, now can I write h theta of x into h theta of x is equal to 1 by 1 plus e to the power of minus z. Now why we are writing like this? Because I just wanted to squash this line like this and like this between 0 and 1. Okay, so that's why I'm writing this equation like this. Now this is called as sigmoid function. This is called as sigmoid function or logistic function. Logistic function, right? Now if I can directly substitute h theta of x is equal to, I can just write 1 plus e to the power of, I already have assigned z is equal to theta naught plus theta 1 into x, right? Now what I'm trying to do here is, as I have shown you in the Excel sheet in our earlier video, now to uh, I just wanted to draw a graph here, um, because I'm just turning this line into logistic regression. Okay, turning linear regression to logistic regression. Let's see what is happening here. Now I have a value from 0 to z here. Okay, and this is from 0, and this is on the x-axis we have z. Okay, on the y-axis we have g of z, which is 1 by 1 plus e to the power of minus z, g of z. So I can write like this, and this is my sigmoid function. I've shown you, right, like in the Excel sheet. You can see it here. On the x-axis I have z, on the x-axis I have z, on the y-axis I have this sigmoid function. I'm just representing this sigmoid function as g of z. Okay, now we have seen the graph, like it is just dividing at 0.5. Now I can draw a graph something like this, right? Now I can say, I can write an equation here. G of z is greater than or equal to 5, greater than or equal to 5 when z is greater than or equal to 0. I can also write in another way, g of z is less than 0.5 when when z is less than 0, right? So now this is about hypothesis representation. Now let's talk about the decision boundary. Let's talk about the decision boundary. Now, we expect our classifier to give some set of outputs or classes, right, based on the probability. Like when we pass the inputs through the prediction function, we need to get the probability score between 0 and 1. Okay. Now, in this example, you can see that let's take them like a pass or fail here. Let's take them pass or fail, right? Now, pass is 1 and fail is 0. Okay. Now, we basically decide with a threshold value above which we classify values into class 1. Okay. And of the values goes below the threshold, then we classify it is in class 2. That means which is having a fail category here. Now, as we have shown in this graph, we have chosen the threshold here as zero point 0.5. We have chosen the threshold here as zero point 0.5. If the prediction function returned to a value called zero point 0.7, suppose if we have got somewhere around zero point 0.7, then we would classify that observation as pass, right? Like we have talked earlier. Now, if our prediction returned a value of zero point 0.2 somewhere here, and this line will be like somewhere like this here, which may be 0.25, right? Now we will classify that observation as fail, right? So this is it in this video. In the next video, and in the next video we'll talk about the cost function.